Welcome to DP Tutorials by Donnie Jarwa. In this brief teaching module, we will emphasize on the relation or the expression of electric field as a gradient of electric potential. Now, we already know that when we have a point charge or any charge system, there will be electric field produced by that system or produced by that point charge. Say, if let at point O there be a source charge plus Q. Due to the source charge, the electric field produced by it, let that electric field be E. Let the electric field produced by the source charge be E. And the strength of this electric field be up to point P such that the distance between point O and point P is R. Distance between point O and point P is R. Now, if I consider a small test charge plus Q located at a finite position, say at infinity, then if I want to do some work by bringing that test charge C up to that point, I have to do work done. That means work done has to be done on that charge in order to carry from an infinite position up to the point. See, if I carry up to this point where this is the point where electric field due to the source charge is experienced, then again I have to do some work. So again, our brief idea is that the work done, the electric potential is defined as the work done in moving that test charge. So this is our basic concept relating to electric potential. But over here, since we are having this point charge plus Q, we need to write a relationship of electric potential of the point charge at point P, which is at a distance r away from the point O. So what is that equation? Okay, we have done this relation. Okay, the electric potential V, let us reiterate and rewrite this relation. The electric potential V is given by the expression 1 by 4 pi, okay, 1 by 4 pi epsilon naught Q divided by R. Q divided by R. So from here, this is your, let us mark that as equation 1. Then this R is nothing but the distance from the point charge Q to point P. If we want to find the relationship, how will you establish electric potential in order? How will you establish, electric field from the given condition of V? Okay, from the given condition of V. How will you establish E? Okay, how will you establish electric field from the given condition of what? From the given condition of electric potential. So what do you have to do? Okay, what do you have to do? Let us take one logical step, and that is by differentiating, that equation 1. Okay, if we differentiate that equation 1, we have to differentiating that equation 1. But when we differentiate equations, keep in mind that we have to differentiate with respect to some variable. What is the variable which keeps on changing over here? The variable is the distance. That means the distance might vary, okay, between all these points, okay. So you have to take the differentiation with respect to R. So when we take the differentiation with respect to R, that means we have to differentiate both sides of equation 1. So this will be ddr. Okay, it will be ddr. ddr of what? Okay, ddr of what? ddr of V. Okay. So let me write properly. This will be ddr of V. Or it is simply, you can write as 1 dV upon dr. That is only the left hand side. Then you have to differentiate the right hand side also. It will be what? ddr. ddr 1 by 4 pi epsilon naught Q divided by R. Then when you look at this quantity within the bracket, this Q and even this 4 pi, okay, are constant quantity and they are independent of dr. So which means that over here we have only differentiation of ddr of, we are left with only r, so it will be what? 1 by r. So that is the differentiation. So when we differentiate this term, okay, we get some final steps. So from here we can write this as ddr of r to the power minus 1 in terms of exponential form. Okay, So from here, differentiation of that r to the power minus 1, okay, we can make use of this result from differentiation. ddx of x to the power n is nx n to the power minus 1, provided if n should not be equal to 1. Okay. So we make use of this formula, then we will get minus 1, okay, r to the power minus 1 minus 1. And then from here, you'll get q divided by 4 pi epsilon naught, okay, epsilon naught, negative sign from here, and then you'll get r to the power minus 2. But what is that r to the power minus 2? That r to the power minus 2, I can rewrite this as 1 by 4 pi, okay, epsilon naught, okay, we have this q, and this r to the power minus 2, we can write as what? We can write as r square. R to the power minus 2 can be written as 1 by r square. So we have come across this relationship. What is that relation? That relation is nothing but the electric field due to a point charge. If we recall our previous knowledge, okay, the electric field due to a point charge takes this formula: E equal 1 by 4 pi, okay, E equal 1 by 4 pi epsilon naught Q divided by what? Q divided by r square. This is what? This is the electric field intensity. Okay? Electric field intensity due to a point charge. Okay? This is the electric field intensity due to a point charge. Okay? Due to a point charge. So from here, which means that we can rewrite this equation. Yeah, we can rewrite this equation in this form. Minus, that means this term is nothing but the electric field. So we can write as minus E, which means that this is what? dV. Right from here, this will be dV by what? dV by dr. This is one way of writing. Another way, we can also express that. Okay, we can also express that E is equal to negative. Okay? E is equal to negative. E equal negative of dV upon dr. dV upon dr. So that is the relation. Okay, that is the relation of the electric field in terms of the potential, and it is nothing but the gradient. Okay, it's nothing but the gradient. That means the gradient of the potential. The gradient of the potential is the electric field. That means electric potential gradient. This is electric potential. When I say gradient, that means ddr. ddr is nothing but we define this as the rate, or we define this as what? As the gradient. So we define that as the gradient. So ddr of what? Of V. What is V? Potential. So the rate of change of electric potential, that means ddr of V, rate of change of potential, is equal to 1 is equal to the electric field. So the electric potential gradient is defined as a rate of change of potential gradient in an electric field with respect to the distance from the source charge. And keep in mind that this electric potential, it measures the rate of change of electric field, the rate of change of electric field as we move away from the source charge, which means that as distance increases, see, if I take this as the plus charge, okay, and if I take this distance from point O up to point P, that means as distance increases, okay, as distance increases, the electric potential will decrease. Okay, the electric potential will decrease. It decreases as a function of what? It decreases as a function of electric field, or potential, it decreases as a function of electric field, or electric field decreases as a function of potential. So all these discussions you have to remember, because these are important from examination point of view. Just go through the discussion so that you will understand and comprehend. Thank you.